All right, hello everyone. So welcome to the lecture for carboxylic acid. All right, guys. So today we'll learn about carboxylic acids, as in we'll learn the nomenclature in this video. So, guys, basically we have learned different functional groups. This one is called carboxylic acid, and let's first learn how to identify the functional group. So guys, this is another functional group that happens to have the C double bond O, which we call carbonyl, if you guys remember. So carbonyl is C double bond O. We have learned many functional groups so far that had carbonyl, including the aldehydes. We learned ketones, and today we're learning the carboxylic acid. So once we learn the carboxylic acid, we'll later on be learning in other videos the derivatives or carboxylic acids. For instance, we're going to be learning esters and amides and anhydrides and things like that. Okay, so first of all, let's talk about the carboxylic acid. So carboxylic acid happens to have that same carbonyl C double bond O, but then it also happens to have an OH on the other side. So far we learned for the aldehydes. Aldehydes, if you guys remember, had the C double bond O with the hydrogen. So we learned that aldehydes are basically the carbonyls at the very edge of the molecule. So that's why you have the hydrogen. There is nothing else on this side. So those were aldehydes. Now, the ketones, if you guys remember, they had basically carbons on both the sides. The carbonyl was surrounded by the carbons. Now, in the case of acids, acids are the one that have the C double bond O and then have the OH. So you can see actually it has the carbonyl portion, so the word carbo, and then it also happens to have the OH. And you guys remember OH is called hydroxyl. So that's where the term oxyl is coming from. So the carbo and the oxyl makes the carboxylic acid. Okay, so it has the carbonyl component and the OH component. Okay, now with that being said, if you look at the more examples, uh, we'll learn how to name these molecules basically. Now, why they're called acids, we'll be covering that in a later video. But let's now begin with the naming, okay? So remember for naming the carboxylic acids, so the carboxylic acids, oops, so the carboxylic acids, they used the suffix oic acid. So the suffix used is OIC, oic acid. So just like alcohol, we're using OL, aldehydes, we're using AL at the very end of the name of the molecule, like ethanol or ethanol, and they will tell you if you're working with an alcohol or aldehyde. Similarly, for the carboxylic acids, we use a suffix, so the words that you put at the very end of the molecule, and in this case, it's going to be oic acid. Okay. All right. So let's take a simple example. We'll work with a molecule that has, let's say, a structure like this, and you're looking at again this part, the C double bond OH. This part is identifying this molecule to be carboxylic acid. Now, the numbering will always start at number 1, where the carboxylic acid is. By the way, guys, carboxylic acid, if you guys remember, we looked at the priority list for the functional group, like who has the highest priority. Carboxylic acids were on the top. So, so actually, carboxylic acid, since they're always highest priority, you will never be actually numbering the actual oic acid. Okay, so it will be by default that uh, carboxylic acid will be at the very first position. So this will be, if we had to number it for some other reason, if we had a substituent or something like that, you always start counting from this carbon, which has the carbonyl. Okay. All right. So this has 6 carbons. Okay. So if we have 6 carbons, what name do we use? So for 6 carbons, we use the term hexane. Now, guys, since we are going to be adding the oic acid in the back, we have to drop this E. So let's remove this E. So you stop at N, so hexane, and then you add, remember we learned oic acid, you just add that at the end. Okay, so hexanoic acid. Okay, so let's keep doing some more examples. So now, guys, let's see if we happen to have, again, a molecule, which again is an acid. And let's say it has a double bond sitting here. Of course, as said before, the carboxylic acids have the highest priority. So don't even think of giving the double bond a smaller number. So this is how this should be numbered. Okay, so again, first thing first, if you're trying to name the last name is always, you know, the main chain. So the main chain has 5 carbons, so it should be called pentane. And again, since the main chain has the carboxylic acid, you will just add oic acid at the end. So we got the last name, which is pentanoic acid. Okay. Now, of course, since we have a double bond, we need to tell that we have a double bond. Now, how do you tell there's a double bond? So calling this pentane with an AN is going to be wrong. Okay. So we need to go back and change pentane to pentene. Okay, so this will tell me that we have a double bond. So pentenoic acid. Now again, the problem is this does not tell me whether a double bond is sitting between the second and third carbon, or the third or fourth, or fourth or fifth. So we have to number this as well. So you have to just tell the number for the double bond, and this 3 will belong to this ene. So 3-pentenoic acid, and that will be the answer. Okay.